So, hello everyone, let's continue the course. We stopped here on other techniques on sort them cards. We just did the first part, that was to add a comparable interface here to the card. And here it is, the compare to. Now we are going to part 2, hand. Create a class and represent the card in a player's hand. Add the following method to the class. Add the card to the hand. Public void print. Print the card in the hand as shown in the example below. Alright. Use an array list to store the cards. Part 3, sorting the hand. Add a method public void sort to the hand class, which sorts the cards in the hand. After sorting, the cards are printed in order. Output. Comparing hands. In a card game, hands are ranked based on the sum value of its cards. Modify the hand class to be comparable based on this criteria. That is, change the class. Change the class so that the interface comparable hand applies to it. Here's an example of a program that compares the hands. Sorting cards with different criteria. What if we want to sort the cards in different ways? Example, sorting all the cards of the same suit in a row. Class can only have one comparative method. We'll need something else to sort the cards into a different order. Alternative sorting systems are possible through different sorting classes, which a class must have the comparator card interface. An object of the sorting class will then compare two cards give these parameters. The class only has one method. Compare card C1, card C2, which returns a negative value if the card C1 should be sorted before card C2, a positive value. If card C2 comes before card C1 and 0 if they are equal. The idea is to create a different sorting class for each different way. Sorting the cards, example, cards of the same suit in a row. Sorting the card by suit. Use the same order as with the comparative method. Clubs first, diamond second, heart third, spade last. Sorting still works with the sort method of collection class. As its other parameters, the method now receives the object that has the sorting logic. Sorting object can also be created directly when sort method is called. It can even be done with the lambda function without even creating the sorting class. You can learn more about creating sorting classes here. Now create a class by suit in random order. Class that has the comparator interface, which sorts the card the same order as in the above example. Except that now the cards are sorted by value inside their suit. Part 6. Sorting the hand by suit. Add a method public void sort by suit to class hand. Then the method call sort the cards in the hand with the same logic in the previous part. After being sorted, cards are printed in the following order. Finally, another one done. I spent down more than 1 hour here. 6 parts, 6 points, alright. But anyways, let's continue. Just take a screenshot here. Close that one here and open. In fact, let's respond to the summary. Please take a moment to answer the quiz. Thank you. I know what the concept stream means. Yeah. I'm able to process data using streams. Yeah. I'm able to use Java's built-in comparable interface. I'm able to sort a list of objects using Java's built-in tools. I'm able to use enumerate types. I'm able to write regular instruction. I know cases where using an iterator is beneficial. Okay, now part 11. We are getting closer to the part 12, where we gonna start using Java effects. But anyways, in the part 11, you will learn to decipher simple class diagrams. You'll become familiar with the package in Java and learn what the different parts of an import statement means. You practice using exception in Java, how to throw a handle and handle them. You'll take another look at reading data from a file and learn to write data to a file. Alright, class diagram. Let's open the exercises now. Oops. From here to here. What? Why? What the f? Anyways, let's select one by one here. Alright, open. Class diagram. Learning objectives. Know how to draw class diagrams and how to describe classes in their attributes, constructor, and methods. Know how to describe connection between classes and describe inheritance and interface implementation. Can implement a class based on a class diagram. A class diagram is a diagram used in design and modeling software to describe classes and their relationships. Class diagrams enable us to model software in a high level of abstraction and without having to look at the source code. Classes in a class diagram correspond with classes in the source code. The class diagram shows the name and attributes of the classes, connections between the classes, and sometimes also the method of the classes. Next, we will get familiar with creating and reading class diagrams using UML, using a unified modeling language. In short, the classes diagrams drawn by different people can be read and understood by everyone familiar with the language. Describing class and class attributes. First, we will describe one class and its attributes. Below is the source code for a class called person, which has two class attributes, name and age. In a class diagram, the class is represented by a rectangle with the name of the class written on top. A line below the name of the class divides the name from the list of attributes. names and types of the classes variable. The attributes are written one attribute per line. In a class diagram, class attributes are written attribute name, attribute type, a plus before the attribute name means the attribute is public, and a minus means the attribute is private. Person class with a private variable called name, a private int variable called age. Describing class constructor. Below we have the source code for a constructor for our person class. In a class diagram, we'll list the constructor and our other method. Below the attributes, a line below the attributes list separates it from the method list. Written with plus in a class diagram, we'll list the constructor and our other method. Methods are written with plus minus dependent on the visibility of the method. Method name, parameters, and their types. The constructor above is written person, initial name string. The parameters are written in the same way. Class attributes are. Nice. Describing class method. Below we have added a method print person, which returns void to the person class. Root class person, private int string name, private int age. In a class diagram, we list all classes, methods including the constructors are listed first and then all class method. We also write the return type of a method in the class diagram. Alright. Person attributes, variable name, variable int, variable string fact and int, a constructor person public, they receive a string, and person public without parameters, and void no return. A class diagram describes classes, constructor, and methods. A class diagram describes classes and their attributes, constructor, and method, as well as the connection between classes. However, a class diagram tells us nothing about the implementation of the constructor or the methods. Therefore, a class diagram describes the structure of an object, but not its functionality. For example, the method printPerson uses the class attributes name and age, but this cannot be seen from the class diagram. Below we have added the method getName to the person, which returns the name of the person. Customer, the class diagram below shows that the class customer implemented the class in the exercise. Book and plain. The class diagram below depicts the classes book and plain. Implement the class in the exercise. Name, author, count. Right. Auto. Introduction.
Non più tra i farfalloni amoroso, notte e giorno di torno girando, delle belle turbando al riposo.
Alright. Connections between classes. In a class diagram, the connection between classes are shown as arrows. The arrows also show the direction of the connection. Below we have a class book. If we add a variable author, type of which is person, in the source code, the variable is declared like all other class variables. In a class diagram, variables which refer to other objects are not written, but the rest of the class attributes but are shown as connections between the classes. In the class diagram below, we have the classes person and book, and the connections between them.
Quando stacchi stretto sacco, schioppo in spalla, sciabla a fianco, collo dritto, uso franco, un gran casco, un gran turbante, moto.
The arrows show the direction of the connection. The connection above shows that book knows its author, but a person does not know about books they are the author of. We can also add a label to the arrow, describe the connection. In the above diagram, the arrow has a company. Is that so? Accompanying label telling us that a book has an author. Book, author, book and author. If a book has multiple authors, the authors are suited to a list. In the class diagram, this situation is described by adding a star to the end of the arrow showing the connection between the classes. The star tells us that a book can have between 0 and a limited number of authors. Below we have not amended the label to describe the multiplicity of the connection, but it would be a good idea for the sake of clarity. Class methods are described just like we did before. Below we have added method get authors and add that author to the book class. We could add the type of the elements in the array list. Array list person and allow describing the connection author to the class diagram above. When ticket in the class diagram below, the classes showing ticket and their connection are depicted. The star is at the ticket end of the connection. In this case, the star gives some extra information of the connection, even though a show doesn't know about the tickets that have been sold to it. You can still sell many tickets to one show. Implement the classes in the class diagram in the exercise base. So a ticket has access to the show, access to show, and show have an unlimited number of tickets. Movie time. I have to import the list. Import. Yeah. Never. Class show must have two max attributes. There were three. Less. 1, 2, 3. No. If we do this is correct. Kind of funny. But that makes sense. Look at now with the overview. Anyways, if there is no arrowhead in a connection, both classes know about each other. Alright, that makes sense. Below is an example where a book knows about its author and a person knows about the book they have written. As you can see, by default, if there is no star on the connection is singular. The classes above are interesting, because a person can only have one book. Another, if a person can have multiple books, and a book can have multiple authors, we add a star to both ends of the connection. We're back in the USSR. A student in university. 2 classes. Student in university. As well as the connection between them. Implement these classes in the exercise base. Yeah. The student university. No reference. The student was found to university. What the hell? This isn't a reference. No reference from student. Oh, that makes sense. From student was found to university. Alright. Describe inheritance. In the class diagram, inheritance is described by an arrow. It's a triangle. The triangle points to the class being inherited from. In the below example, the engine inherited the class part. Subclass. In the below example, the class diagram describes the classes from the product warehouse exercise. The product warehouse exercise class inherits the product warehouse class, which in turn inherits the warehouse class. Change history is a separate class connected to the product warehouse. With history, knows about the change history, but the change history does not know about the product warehouse with history. Let's take this image and see what the Gemini do with it. In fact, the AI is only analyzing the image. Anyways, inheritance of abstract class. An abstract class is described almost the same way as a regular classes. However, we add the description abstract above the name of the class. The name of the class and its abstract methods are also written in cursive. I forgot that there is no arrow here or here, so the two classes connect to each other. The player in the boot. Boot it's the initialization, and also boot bot that you places on your feet. But anyways, the class player in bot and the connection between them are depicted in the class diagram below. Implement these classes in the exercise. Zero attributes. So how this class can access this one? Oh, it's inheritance. Right. The bot inherit the player. Subclass, superclass. Describing interfaces. In a class diagram, its definitions are written. Interface, the name of the interface. Below we describe an interface readable. Methods are described just like they are for class. Implementing an interface is shown as a dashed arrow with a triangle arrowhead. Below we describe a situation where the book implements interface readable. Below you will see the interface, savable, and the class person. Implement the content of this class diagram in the exercise base. Se quer dinheiro, só se quer amar, se quer amar, se quer amar de tua maneira. Quer amor sincero, isso é que eu espero. Te amo nessa vida que eu te amo. Eu te quero bem. Olhando, só te ver sorrir, só te ver cantando. Quando a gente ama, conseguir dinheiro. Só se quer amar, se quer amar, se quer amar. Quero dinheiro, quero amor sincero. É que eu espero. Só se quer amar. Void. Load. Void save, void delete, void load. Implements. Divable. Right. All these should be drawn. The class diagrams are excellent example. The class diagrams are excellent way to describe a problem and a problem domain to others. They are particularly useful when a programmer is designing a program with multiple classes. Often a class diagram is drawn on a whiteboard or a large sheet of paper during the design phase. Class diagrams should be thought of as helpful tools to build a program, which can be thrown away afterwards. You should not use too much energy to think about the correctness and details of the modeling. Language. Class diagrams should also be drawn in a suitable level of abstraction. For example, if you have 10 of classes, it might not be worth describing each attribute and each method of it might not be worth describing each attribute and each method of each class. Getting a good overview of the program structure is the most important. The class diagrams here have been drawn using YUML, Gradely, and Draw.io. NetBeans also has tools for drawing class diagrams. For example, EasyUML draws class diagram from the source code. That one is interesting. Not secure. Okay. Figure class diagram. Below you will see a somewhat larger class diagram. In each are the classes A, B, C, D, and E. As well as the interfaces AI. In fact, it's IA, IB, and IC create these classes and interfaces in the exercise. Você mais do que sei. what that arrow means. I'm gonna suppose that means amend. In fact, it doesn't mean the same thing as the interface con. It could be a arrayless. AI new array less private or util arrayless. Let's see what happens. Oh, in fact, it's not an array. There is no star. It's just a simple call. Yeah. Alright. A little bit complex. Class diagram with the help of YUML service. Use the service on the website YUML.me. A is a, E is a, and E is Y. It's U, in fact. Anyways, to create a class diagram that represents the following classes, paste the textual representation used to create the class diagram from YUML service into the answer field. Alright, I'm not very good with class diagrams, but I'll try to do something here. Let's try to do here. I need a public class. Teacher. So, as you can see, the Gemini is helping me do the UML here, but some things he's correcting is classified as errors. In fact, was intended because, like, There is no private teacher on my UML here. It wasn't in the past. Now it is. But if you have a look here, like this book, you can see there is no int. There is no private variable, reference variable called author, because here it is. You know, the MOOC.FI was teaching us, as you can see, if we have a reference variable, we don't need to add here on the UML. We add on the UML of the class. We add on the arrow, as you can see here. But the Gemini classifies this action as an error. I don't know if I trust on the Gemini or the MOOC.FI. But anyways, just this is just a observation. As you can see here too, there is a book and a person, and a book can have multiple authors. And you can see here there is no reference variable here calling person, but here's it is on the code. It is, but on the YUML, no, there is not. So I don't know which one is more correct, the Gemini or the MOOC.FI, but I'll trust Gemini on that one. Okay. Learning, let's add this. What? It's minus teacher arraylet. Let's use an array list. Now I'm seeing why the MOOC.FI wasn't adding the array list here. Private teachers. Teacher. So to add here teacher. Teacher. Teachers, in fact. Teachers. In fact, this is wrong. I need to separate them with this. Now it seems more correct. In fact, I want to make that work, the Gemini style, but this isn't. I don't know why. There's no constructor here. Oh, there it is. Anyways, I'm gonna send this to MOOC.FI for the sake of time. We spent a bunch of here for something that maybe don't work. Who knows? Alright, another one done. Let's go to package. Let's also close that these two here. Alright. Packages. Learning objectives. You know what package are and can place classes in them. You know what the import statement used in Java is composed of. That's the number of classes implemented for the program grows. Remembering all the functionality and method become more difficult. What helps in naming the classes in a sensible manner and planning them so that each class has one clear responsibility. In addition to these measures, it's wise to divide the classes into packages. Classes in one package might share functionality, purpose, or some other logical property. Packages are practically directories in which the source code file are organized. IDE offers existing tool for package management. Up until this point, we have only created classes and an interface in the default package of the source code of the source package folder of the project. You can create a new package in NetBeans by right-clicking on the source code package section with which contains the project's package, and then select new Java package. You can create classes inside a package in the same way you can in the default package. Below, we create the class program in the newly created package library. At the package of a class, the package in which the class is stored is noted at the beginning of the source code file with the statement package name of package below the class program is in the package library. Every package, including the default package, may contain other packages. For instance, in the package definition package library domain, the package domain is inside the package library. The word domain is often used to refer to the store space of the classes that represent the concept of the problem domain. For example, the class book could be inside the package library domain, as it represents a concept in the library application. A class can access classes inside a package by using the import statement. The class book in the package library domain is made available for use with the statement import library domain book. Import statements that are used to import classes are placed in the source code file after the package definition. From this point on, nearly all of the exercise we use package. Let's begin by creating our first very own package. Alright, let's close that one. Projects, first package. There is a package called MOOC. Include in the... I was always calling this MOOC, but I don't really know the pronunciation. MOOC. I call MOOC, but it's MOOC.FI. Package called MOOC include the exercise. We will create the functionality of the program inside this package and the package UI inside the package MOOC, after which the package MOOC UI should be available. And add an interface called user interface in it. The interface user In the interface, user interface define the method void update. Alright. Add the package UI inside the mock. UI. Oh, here it is. Mock UI. Oh, it's empty. I think it's because that is the MOOC UI is outside the MOOC here. The package inside. An interface, user interface, void update, test user interface. In the same package, create the class test interface that implements the user interface. Implement the method public void update required by the user interface, so that the only thing it does is print the string updating UI by calling the method listen out println. Alright, that's interface. Part 3 application logic. Then create the package MOOC logic. Create the class application logic, and the functionality that the application logic offers should be as follows. Public application logic. The constructor of the application logic class, it receives the parameter a class that implements the user interface. Nota bene, for application logic to see the interface, it must be imported at the line import MOOC UI user interface at the beginning of the file. Once the string application logic is working, the number of times that is indicated by the variable times. After each print, the method should call the update method of the object that was received as a constructor parameter, which implements the user interface. Alright. Application logic. Import package, import MOOC. There's one. Oh, here it is. How do I call this? UI updates? Maybe? Private. This UI. I think the program will do something like that. Yeah. We don't need to implement the user interface. Free package. Within the exercise base, create three package. Here. Free package A, B, and C. Create class A inside the package A. Create class B inside the package B. Create and class C inside the package B. The classes don't need object variable constructors or methods. A. Directory structure in a file system. Project you see in NetBeans is in your computer's file system or on a centralized server. The project directory's source main Java contains the source code files of the program. If the package of a class is a library, the class is stored inside the source main Java library folder of the source code directory. You can also check the concrete project structure NetBeans, the Files tab, which is normally next to the Project tab if you cannot see the File tab. You can make it appear by choosing the option file on the drop-down menu window. Application development is normally done in the Project tab, where NetBeans hides unimportant files from the program. Package and access modifiers. Till now, we've used two access modifiers. The modifier private is used to define variables and methods that are visible. They are only visible inside the class where they're defined. They cannot be used from outside the class. The methods and variables defined with public, on the other hand, are visible or available for everyone to use. If you create an object of the user interface class above its constructor and start method are called from anywhere in the program, the method printTitle and the variable scanner are available only from within the class. If the access modifier is missing, the method and variables are only visible inside the same package. We call this the default or package modifier. Let's change the example above so that the method printTitle has the package access modifier. Now the class is inside the same package. That is, the classes inside the package library UI can use the method printTitle. If a class is in a different package, the method printTitle cannot be called. In the example below, the class name is in the package library as the printTitle method is in the package library UI and has the package access modifier. It cannot be used. A larger example, flight control. Let's take a look at a program that offers a test UI for adding and examining our airplanes in flight. The user interface of the program looks like this. Alright, another break. Alright. Let's look first for adding the user. Okay. There are many concepts of the problem domain in the program, and the essential ones are airplane and flight. Each flight also involves a place, places of departure, and destination. In addition to the concepts that represent the problem domain, the program also contains a test UI. Oh, there. The test UI and a class through which the test UI uses the concept. The package structure of the program could look like the following. For example, flight control includes the main program class that is needed to start the program. Flight control domain includes the classes that represent concept of the problem domain. Are plane, flight, and place. Flight control logic includes the functionality that is used to control the application. Flight control UI includes the textual user interface. In the next subchapter, we'll list one possible organization for the operation of the program, including the main program class. Classes that represent concept of the problem domain. The classes that represent concept of the problem domain are often placed inside a package called the main. As the entirety of the application is inside the package flight control. Let's place the package domain inside the package flight control. Concept of the problem domain are represented by the classes place, airplane, and flight. Application logic. The application logic is typically kept separate from the classes that represent concept of the problem domain. In our example, the application logic is stored in the package logic. Application logic includes the functionality to add airplanes and flights, and to list them. Flight control in normal words. Above is describe a class. Flight control. Explain your own words how the class hopefully works. In addition to the rough description, also explain why planes, the flights and places are saved in a hash map. How the method airplane works. How the method flight works. Tango, place. There is 3. Hard work. 1. did not say what is a better word. The sign of the teacher place, target place, and the airplane. Oh, the application logic. Quick way. Airplanes fly. Place. Airplane fly place. Alright. Like to New York. All the matter airplanes at airplane works. The method creates a new airplane class that and then add names to the hash created earlier. And how the method addFly works. Then the method it all place the teacher and the nation. It isn't there yet. But there. This places which map places. After that, it all create a flight object, adding the plane, place, teacher, and destination, and in the end, put all of this on the hash map. Right. Let's try to finish that package subchapter. That's a user interface. The user interface is separate from the application logic and the classes that represent the problem domain. In this example, the user interface is stored in the package UI. While true, so all of this class does is interface so that you will use the other classes to do the hard work, the back end. It's for airplane. In this exercise, you will implement the application that was described above. You are free to design the structure as you wish, or you can follow the structure sketch it out above. The appearance of the user interface and the required commands are predefined. This exercise is worth 2 normal exercise points. For the test work, you can only create one scanner object in your program to read the input. In this exercise, you will implement a flight control application. It is used to control the airplane and their flight routes. The system always knows the identifier and the capacity of an airplane. The flight information consists of the user in the airplane. The picture airport ID, example how isn't how other pronunciation how. In fact, it is hell. Example hell in the destination airport ID ball. There can be multiple airplanes and flights. Same airplane can be used to make several flights. The application should operate in 2 parts. First, the user enters information about airplanes and the flights in the airport asset control, after which the program offers the flight information service for the user. There are 3 operations in this latter flight control. Print the airplane, print the flight, and print the information of a single airplane. In addition, the user may exit the program by choosing the option X. If the user enters an invalid command, the program asks for a command again. The program should start when the main method of the main class inside the package flight control is executed. Example output of the program is presented below. Part 1, Part 2. Nota bene, for the purpose of the test, it is essential that user interface work exactly as is described above. You should probably copy the option printed by the program from here to your code. The test won't assume that your program is prepared to handle improper input. So, it just We'll just copy the code we see before. The main. Please. Slide. Airplane. Now we have the three classes. Now we will add the logic and flight control. Flight control. And there is the test UI. What if we just copy the test UI? What happens? Airplane is missing. An airplane. One, two, three, four. It's missing the flight control. Oh, one, two. An airplane. Let's bring this code to the NetBeans. If that JetBeans, I always confuse that. Okay. Airplane. Oh, in fact, I need to delete this. We need to create the package first. Flight control UI. The main, and the last one is the main logic. Yeah, logic. Airplane. Place. control. Let's go to the NetBeans here, and let's see first my UI. What about this? Nothing happened. So we need to correct the problems here. Oh, we could do that. Let's see. Another airplane. Oh, we couldn't really do that. This fly scanner. Next. Let's see what's there. Flight. There's no ad here. In fact, we can fix that problem. Scanner. If we delete this, what happened? This, of course, isn't the correct answer, because if we do that, nothing will be added. You can just look here. As you can see, nothing happened. But look, answer in an airplane. the ID, and the next line. Or the ID is an integer. Flight control. Flight control at string in capacity. Something here I need to fix. I want to finish that one and then go for the lunchtime. And I think I'm able to fix that one. I'm able to fix that one right now when I'm talking. Under airplane. Airplane. Give the airplane ID. String ID and the capacity. Ask for airplane. Oh, here. What is missing here? Isn't that one? Neither is that one. Something is missing. And an action. Make sure that the print of the program matches exactly the example. Your program print. Oh, where's the main? The main code are here. Do here first. Import. In fact, let's just use the intelligent. Sure. Like, sure. Oh, that's why there is no UI sort. In fact, there is missing the main here. Pick all of this to here. Main. In fact, it's the problem isn't the main. In fact, is the main. I thought there is something in the code because this is just calling the classes to start. Like console scanner, it says UI. Okay. So I'm gonna do a lunch break now. You all after an hour.
Here.
No, I'm not a writer.
Okay.
Give up on my way home, yeah. Wouldn't it be crazy? Oh, but you still amaze me. Wouldn't it be crazy? Oh, but you still amaze me. Wouldn't it be crazy? Oh, but you still amaze me. Wouldn't it be crazy? Oh, but you still amaze me. Give up on my way home, yeah. Give up on my way home, yeah. Wouldn't it be crazy? Oh, but you still amaze me. Wouldn't it be crazy? Oh, but you still amaze me. Wouldn't it be crazy? Oh, but you still amaze me. Wouldn't it be crazy? Oh, but you still amaze me. Give up on my way home, yeah.
This is the MOOC. For those who
Give it one more chance. Worrying, honey. Give it one more chance. Worrying, honey. Give it one more chance. Worrying, honey. Give it one more chance. Worrying, more chance. More chance.
So what's after 1? Let's continue the course. But now there's only 30 minutes remaining. We'd like do one exercise and then it's over for today. The clock is here. Everything's fine. Okay, let's finish that. Exception. Learn objectives. Know what exception are and how to handle them. And through exceptions, know that some exceptions have to be handled and that some exceptions do not have to be handled. In a program, execution ends with an error. An exception is thrown. For example, a program might call a method with a new reference and throw a new pointer exception, or the program might try to refer to an element outside an array and result in an index out of bound exception as well. Some exception we have to always prepare for, such as errors when reading from a file or errors related to problems with a network connection. We do not have to prepare for runtime exception, such as the new pointer exception beforehand. Java will always let you know if your code has a statement or an expression with which can throw an error you can have to prepare for. Handling exception. We use the try-catch exception block structure to handle exception. The keyword try sorts a block containing the code with which might throw an exception. The block sorting with the keyword catch defines what happens if an exception is thrown in the try block. The keyword catch is followed by the type with the exception handled by that block. For example, our exceptions. We use the keyword catch because causing an exception is referred to as throwing an exception. As mentioned above, we do not have to prepare for runtime exceptions such as the new pointer exception. We do not have to handle this kind of exception till the program execution stops if an error caused the exception to be thrown. Next, we will look at one such situation parsing. It's parsing or parsing. Parsing brings to integer. We have used the parsing int method of the integer class before. The method throws a number format exception. The string is it has been given cannot be parsed into an integer. In fact, this is funny because on most parts of the course, it uses the value of instead of the parsing int. But anyway. The above program is through an error. The above program throws an error if the user input is not a valid number. The exception will cause the program execution to stop. Let's handle the exception. We wrap the call that might throw an exception into a try block. And the code executed if the exception is thrown into a catch block. The code in the catch block is executed immediately if the code in the try block throws an exception. You can demonstrate this by adding a print statement below. The line calling the integer parsed into method in the try block. Nova. The user input, in this case the string now, is given to the integer parsed into method as a parameter. The method throws whenever if the string cannot be parsed into a try with an integer. Note that the code within the catch block is executed only if an exception is thrown. Let's make our integer parser a bit more useful. We'll turn it into a method which prompts the user for a number until they give a valid number. The execution stops only when the user gives a valid number. Exception in resources. There's a separate exception handling for reading operation system. Resources such as files with so-called try with resource exception handling the resource to be opened is added to a non-console report of the try block declaration in brackets. The code below reads all lines from file txt and adds them to an array list. Reading a file might throw an exception, so it requires a try-catch block. The try with resource approach is useful for handling resource because the program closes the usage resource automatically. Now reference to a file can disappear because we do not need them anymore. If the resource are not closed, the operation system sees them as being in use until the program is closed. Method and constructor can throw an exception. There are roughly two categories of exception. They are exception we have to handle and exception we do not have to handle. We can handle exception by wrapping the code into a try-catch block or throwing them out of the method. The code below reads the file given to it as a parameter line by line. Reading a file can throw an exception. For example, the file might not exist, or the program does not have a read sign, or the program does not have read write to the file. This kind of exception has to be handled. We handle with the exception by wrapping the code into a try-catch block. In this example, we do not really care about the exception, but we do print a message to the user about it. A programmer can also leave the exception unhandled and shift the responsibility for handling it to whomever calls that method. You can shift the responsibility of handling an exception forward by throwing the exception out of a method and adding notice of this to the declaration of the method. Notice on throwing an exception forward, throws exception type is added before the opening bracket. of a method. Eu quero dinheiro, quero amor sincero, isso que eu espero. Now the method calling the readLines method has to either handle the exception in a try-catch block, or shift the responsibility yet forward. Sometimes the responsibility of handling exception is avoided until the end, and even the main method can throw an exception to the caller. Now the exception is thrown to the program executor or the Java virtual machine. It stops the program execution when an error causing an exception to be thrown occurs. Throwing exception. The throw command throws an exception. For example, a full number format exception can be done with command throw new number format exception. The following code always throw an exception. One exception that the user does not have to prepare for is illegal argument exception. The illegal argument exception tells the user that the value given to a method or constructor as parameters are wrong. It can be used when we want to ensure certain parameters values. Let's create class grade. It gets an integer representing a grade as a constructor parameter. We want the grade fills certain criteria. The grade has to be an integer between 0 and 5. If it is something else, we want to throw an exception. Let's add a conditional statement to the constructor, which checks if the grade fills the criteria. If it does not, we throw the illegal argument exception. We throw new illegal argument exception. It must be between 0 and 5. Exception happens. Execution will not continue from here. An exception is a runtime exception. Example, legal argument exception. We do not have to worry about it. Throwing it on the method declaration. Let's practice a little parameter validation with the illegal argument exception. There are two classes included with the exercise base. Person and calculator modify the classes in the following manner. The structure of the class person should ensure that the name given as a parameter is not new, empty, or even 4 characters in length. The CA should be between 0 and 120. Some of these conditions are not met. The constructor should throw an illegal. The constructor should throw an illegal argument exception. validating the calculator. The methods of the calculator class should be as follows. The method factorial should only work if the parameter is a non-negative number, 0 or greater. The method binomial coefficient should only work when the parameters are non-negative. If the subset size does not exceed the set size. If these methods receive valid parameters when they are called, they should throw an exception. Alright. There's 5 minutes remaining. I think we can finish that. Types of exception. We said there are roughly 2 categories of exceptions which must be handled. Exceptions which do not have to be handled. Exception which must be handled are exceptions which are checked for during compilation. Due to this, some exceptions have to be prepared with a try-catch block, or by throwing them out of a method that throws attributes in a method declaration. For example, exception related to handling files, including new exception and file not found exception, are this kind of exception. Some exceptions are not checked for during compilation. They can be thrown during exception. During execution, fact, this kind of exception do not have to be handled with a try-catch block. For example, illegal argument exception and new pointer exception are this kind of exception. Exception in interfaces. An interface can have method with throw an exception. For example, the class is implementing the following server interface might throw an exception from the method load method loads or save. Next, we find interface declare a throw exception attribute to a method so that these methods I throw an exception. The class implementing this interface must also have these attributes. However, the class does not have to throw an error, as we can see below. Details of the exception. Catch block defined with which exception to prepare for with catch exception E. The details of the exception are saved to the E variable. The exception class has an useful method, for example, print stack trace. Print the stack trace, which shows how we ended up with an exception. It loads in a stack trace printed by the print stack trace method. We read a stack trace from the bottom up. At the bottom is the first call, so the execution of the program has begun from the main method of the class. Line 29 of the main method of the class calls the print method. Line 43 of the print method has thrown a new pointer exception. The details of an exception are very useful when trying to pinpoint when an error happens. Below is a program written in Java. Okay, so I will just respond that stack trace quiz and then end the live stream. Test the code on your computer. Test the shortcut caused by the execution into the answer field and describe its content line by line in your own words. Finally, explain why the program does not work as intended. The the list isn't initialized. On the statistics class, the method and the num. Missing the initialization in the initialization, yeah, initialization of the list. So the new pointer is given as the list is new and can be, and nothing can be can occurs to it until it is initialized. Yeah, this is that. We try to initialize it. Should work like numbers. Let's, as you can see here, now it's a no such element exception because the list is empty and can give the average. So if you do this, the program should work. If we add something like if number is empty. Oh, in fact, it needs to be out. Yes, and return no value in the list. Oh, in fact, it needs to be a double, so we can just turn 0. Yeah, print the average of the statistical 0, and then tomorrow maybe I do a live stream and we finish that part, that exercise, and that part too. For processing files will be still remaining. But anyways, I see you all tomorrow, or Monday, Saturday or Monday. We all will discover that. See you soon.